All right, Antonio. So if you want to draw two atoms bonding together, the first thing you're going to do is find the atom on the periodic table. So say you're looking for chlorine right here, right? What you're going to do is you're going to find chlorine on the periodic table. So I can type in ptable.com. There's chlorine right here. What group is chlorine in? Yeah, it's one of the nonmetals in group 17. So what we do is we can figure out how many valence electrons it has, the electrons on the outside, by just taking away that one, and we see it has how many? 7 valence electrons. So when I draw it out, it's going to look like this, with 7 electrons around it, right? Now we do that for every atom that we see we're trying to bond, and then we put them together so that all the atoms have satisfied the octet rule, so that their outside shell has all the valence electrons they need. So when we draw them, so if I have something like hydrogen, carbon, and nitrogen, I have to find all 3 of those and draw out the valence electrons for each one. Cool? So it's going to work like this. If I have something like H2S, the first thing I'm going to do is I'm going to find hydrogen and I'm going to find sulfur. How many valence electrons does hydrogen have? In what group is it in? I go to the periodic table. I see hydrogen's right there. It's in group 1. So how many valence electrons does it have? 1, exactly. So I go here, I give it 1 valence electron. Then I look at how many sulfur has. How many does sulfur have? It's right below oxygen. 6. It's in group 16. I can go to my periodic table, find oxygen, there's sulfur. They're both in group 16, so if I take away that 1, how many do they have? 6. So I can draw 6 around sulfur. 1, and you always draw them as far away from each other as possible. 2, 3, 4, 5, 6. The most they can have on a side is 2. So if they have 2 on one side, that's perfect. They can't have more than 2 on one side. You see that? That's why they can have a total of 8 on the outside. That's why we draw Lewis structures. But how many hydrogens do we have here? We have 2. So if we have 2 hydrogens, we're going to have 1, 2 of these. So here's how you draw atoms covalently bonding to each other. First, you draw the central atom, which is going to be carbon or sulfur or one of those in the middle. So I'm going to draw carbon right here. Sulfur right here. How many valence electrons does sulfur have? 1, 2, 3, 4, 5, 6. Now how many more does it need so that it's satisfied? They want 8 total. The octet rule says it wants 8 total. How many does it have right now? Sulfur, this one. 6. So how many more does it want? 2 more. 1 right there and 1 right there. And hydrogens, if you draw hydrogen's Bohr model, they have 1 on the inside. And in the first ring, how many fit in the first ring? Total. 2. 2 fit in the first ring always. So for hydrogen to be satisfied, it wants to get 1 more. For sulfur to be satisfied, it wants to get 2 more. So what's going to happen is I'm going to draw a hydrogen here and a hydrogen here. Because remember, I have 2 hydrogens, H2. See that? And so now I can draw them sharing like this. So when they share, that is what the covalent bond looks like. And to be sure that sulfur has all of the atoms, the electrons it needs, I can count them up. 1, 2, 3, 4, 5, 6, 7, 8. So sulfur satisfied. I can also count the ones for hydrogen. 1, 2, 1, 2. So they're both satisfied. So the way you draw that out is anything that you put in the bond right here in the little circle, connect the dots. and you get H, S, H, with those two extra ones on lone pairs, we call these, on the outsides. And that is H2S right there. That's the final answer. That's how you draw covalent bonds.